Hello all, today in this video I'm going to provide a demo for Python classification using a SVM classification in kidney disease dataset. Already we have done a demo with the same dataset, but the algorithms we used were CNN and ANN from scratch, so that will be found in our channel. So if you are interested means you can check them. So in the same code only we are going to do SVM classification. So initially we are going to import the libraries which we need, and then we are going to call our data set, which is kidney disease data set. In the kidney disease data set you can see it is having several classes, that is 25 rows, 26 columns. In this final classification we are going to make as the target and other, that is the prediction variable. All others will be in the x variable. So other details regarding the data set description is given over here, whether it is a float or object or integer. And here we are going to drop some variables which are having some in the previous itself I would have explained the previous code, like kidney disease classification with CNN and ANN itself I would have explained, but still I would explain here also. Here some data sets have some values other than this sorry, text other than this values. We are going to omit this because in this code which it will accept only values other than this string. So we are going to delete this, but you can see that classification we are going to make it as the prediction variable. It is also in string. So for this we have to change the string into a numerical value. So if you are interested in changing some other features, if you want means also that also you can change it to numerical value. In the others we are going to drop here the classification we are going to replace like CKT and CKT as 1 and not CKT as 0. So in other variables, or if it is in a string, so if you want them means you can just change them as a numerical form. Then we are just describing our x variables and y variables. In the x variables, apart from the classification variable, we are choosing all other variables, and in y we are choosing only the classification, since we have considered it as the prediction variable. Now we are just declaring four variables among them, which is x train, x test, y train, and y test, and then splitting it into these variables are got by splitting it by using the variables x and y. And here we have declared the test size as 0.2, that is testing ratio will be 20% and the training balance training will be 80%. So if you want some other ratio like 70/30 means in the test size, if you want 70/30 means you have to give 0.3, that is 30% for testing and balance 70% for training. Then we are pre-processing our data, that is the X data set. For that we are using standard scaler, and that we are finding the shape. Why we are finding means because in the convolution neural network and artificial neural network we will pass the input shape as the input, but in this SVM we no need to pass. But still, if you, since I am making this as the continuation of the previous video, already I have find, so it is there. So now we are going to see the code for support vector mission, which is SVM. For that we have to import the libraries svc from sklearn.svm. Apart from that we have also import some other metrics, like since we have, if you want to find the classification metrics like confusion matrix, then F1 score, sensitivity, specificity, etc. If you want means you have to just declare this libraries, and so I have declared it. Then I am just making the SVM classifier, and I'm calling the variables like x train and y train. Then I'm just testing or classification, and for that I'm just using this x test variable and y test, then plotting the confusion matrix also. Then we, if you want to find the uh, performance metrics parameters like sensitivity, specificity, and all. For that, I'm just making to print the classification report. So this is the output for the kidney disease classification using this SVM. You can see this is the variables for precision, recall, F1 score, support, accuracy, macro average, and micro average, and also you can see the confusion matrix parameter. So in the next curve, we can just see the kidney disease classification by using hybrid CNN with SVM. Thank you.